Okay, this is an interesting question now and gives you a deep understanding of polar form of a complex number. So we're told that a complex number z has a modulus greater than 1 and three numbers z, z squared and z cubed are shown on the Argand diagram. One of them lies on the imaginary axis as shown. So we have the same complex number z. So if we think about that, z is equal to r cos theta plus I sine theta. Okay, so that's our complex number z. So that would mean that z squared would be r times r by the cos of theta plus I sine theta plus theta. And z cubed would be equal to r times r times r, or as we say cos cubed, or sorry, r cubed, theta plus I sine theta plus theta. So I'm just writing them like that, but we see that as, we'd write that as r cubed by the cos of 3 theta plus I sine of 3 theta. So that's basically what the Myers theorem tells me. Okay, for z squared I multiply the two r's and I add on two angles. For z cubed I multiply 3 r's and I add 3 angles. And in short then that would become r cubed cos 3 theta. Now how does this help us? Well, if we look at, there's a very important sentence here. A complex number z has a modulus greater than 1. Now that if its modulus is greater than 1, the r is greater than 1. So if that r is greater than 1, when I multiply r by another r, it will make it even bigger, a bigger number again, and by another r, a bigger number again. And what does the modulus means? Your modulus means your distance from the origin. So what this would mean is that z would have to be the closest to the origin. And this would also imply that z cubed would be the furthest. Okay, so basically then, marking these in, this must be z because it's the closest to the origin. This must be z squared because it's further from the origin, and this must be z cubed. Okay, now, so the next thing then, I'll just dot those out. Okay, so my first one here, z. Okay, then I have my next one, z squared. And then finally I have my next one, which is z cubed. Okay, now if we look at this then, our first angle, z, or theta, comes right around to here. So that's a theta. Now remember then, what did I say? To get z squared, I have that theta, and I should even then put it in green maybe here, and another theta. Okay, so basically another theta to get me around to there. Okay, now, and then we have a final theta. Okay, so for this one we'll have a red one, and we'll have a green one, and we'll have a blue one. And that must also be theta. Okay, so that must be 3 theta. Now, why is that important? Okay, well, I'm going to rub this out now because I need the space. So what I realized there is, if you look at the numbers z and z squared, they're just kind of numbers in the middle of nowhere. But clearly you can see that z cubed is sitting on the imaginary axis, i.e. at 90 degrees. But we must remember, if we look, it's not exactly 90 degrees, because if you look at z cubed, okay, how many degrees is this from where we started? Well, if you look, it's a full rotation of the circle and another 90 degrees. So the arc of z cubed is 3 theta, right? Because it's the red one, the green one, and the blue one. But that in degrees is equal to a full 360 plus another 90 degrees to get me back to that right angle. So this is why I'm looking at z cubed, because it's the only one landing on an angle that I recognize in the plane. And that gives me 450 degrees. Okay, so that implies then that 3 theta, like we've said there, is 4. So 3 theta is equal to 450 degrees, it says. So that means theta must be 450 degrees divided by 3. So theta is equal to 150 degrees. Okay, so that's a nice one there to get the understanding of what the modulus and the argument of a complex number does.